So in this video we're actually going to determine or come up with the cofactor and adjoint matrices for a given matrix A. So here we have a matrix A and we want to construct the cofactor matrix and the adjoint matrix for A. So step one is to evaluate the cofactors for this matrix. So we start with cofactor from row 1, column 1, and then we're just going to move our way through the matrix. We want to remember that in the cofactor expansion, we have that plus, minus, plus, minus, plus, minus, plus, minus, plus convention that we then multiply by the determinant of the minor matrix. So if we start with the calculation for the cofactor for row 1, column 1, we're in the plus position, so it's going to be plus or positive times the determinant of the minor that goes with row 1, column 1, and the minor matrix we get by striking out row 1, column 1, and then constructing the matrix from the terms that are left. So that's 0, negative 3, 1, 2, and then we calculate this 2 by 2 determinant, so we get 0 times 2 is 0, minus 1 times negative 3 is negative 3, so we get 0 plus 3 equals 3. And that takes care of the first cofactor, and we just walk and grab the next cofactor. So cofactor for row 1, column 2, we're going to be in a plus minus. Row 1, column 2 is in a minus position, so it's going to be opposite of the determinant of the minor matrix that we get when we strike out row 1, column 2. So we want the determinant of 1, 1, 1, 2. So this is going to equal negative 1 times 2 is 2, minus 1 times 1 is 1, 2 minus 1 is 1, times negative 1 is just a negative 1. And now we do cofactor for row 1, column 3. We're in plus minus plus, we're in the plus position, we strike out row 1, column 3, construct the determinant of the minor matrix that's left, so 1, 1, 0, negative 3, so we get 1 times negative 3 is negative 3, minus 0 is just negative 3, and that takes care of the cofactors from the first row. And now we just walk down and do the cofactors for the second row. Cofactor for row 2, column 1 equals, we're in a plus minus position, so it's going to be the opposite of the determinant of the minor matrix that goes with row 2, column 1. So we strike out row 2, column 1, we construct the matrix from what's left and calculate its determinant. So 4, 3, negative 3, 2 equals the opposite of 4 times 2 is 8, minus negative 9, 3 times negative 3. So we wind up with negative 17. And now we do cofactor for row 2, column 2. We're in a plus minus plus position in row 2, column 2. We strike out row 2, column 2, construct the determinant of the remaining terms, so negative 2, 1, 3, 2. And then we do negative 2 times 2 is negative 4, minus 3 times 1 is 3, equals a negative 7. And finally we get the cofactor term for row 2, column 3, which is going to equal, we're in a plus minus position right here, so we do the opposite of the determinant of the minor. We strike out row 2, column 3, negative 2, 4, and 1 and negative 3, which is going to equal the opposite of negative 2 times negative 3 is 6, minus 4 times 1 is 4, 6 minus 4 is 2, so we get negative 2. And finally we're ready to work on the cofactors for row 3, so we just step through and do it. Row 3, column 1 equals, we're in a plus minus plus position right here, so it's going to be the positive determinant that we get when we strike out row 3, column 1. That leaves us with 4, 0, 3, 1, which is going to be equal to 4 times 1 minus 3 times 0 is just 4. Cofactor term for row 3, column 2. We're in a plus minus position right here, so it's going to be the opposite of the determinant. Strike out row 3, column 2. Construct the determinant of the pieces that are left, 3, 1, the entries that are left, equals the opposite of negative 2 times 1 is negative 2, minus 3 times 1 is 3. We get the opposite of negative 5 is positive 5. And we have one last cofactor to calculate, so we calculate the cofactor for row 3, column 3. And now we're in a plus position, plus minus plus minus plus, plus the determinant that we get when we strike out row 3 and column 3, row 3. The pieces that are left are the negative 2, 1, the 4 and the 0, equals negative 2 times 0 is 0, minus 4 times 1 is 4, equals negative 4. And now for the cofactor matrix, let's call him C. We just put the cofactor terms in. Row 1, column 1 becomes row 1, column 1. Row 1, column 2 becomes row 1, column 2. Row 1, column 3 becomes row 1, column 3. Row 2, column 1, we get the negative 17. Row 2, column 2, we get negative 7. Row 2, column 3, we get negative 2. Row 3, column 1, we get 4. Row 3, column 2, we get 5. And row 3, column 3, we get negative 4. So there's the cofactor matrix. And remember that the adjoint of our original matrix A is just going to be the transpose of the cofactor matrix. So row 1 becomes column 1. Row 2 becomes column 2. And row 3 becomes column 3. So there's the cofactor matrix and the adjoint matrix for matrix A.